Hello students, we are solving the IB Math AHL past paper questions and currently we are solving the IB Math AHL May 2023 paper 2 time zone 2 past paper. Today we will be solving the question number 5 of this paper and you will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlist in my channel NS Online Math Tutoring classes. But this is a common question common to both the SL and the HL level students. For the SL students, it is question number 6. And for the HL students, it is question number 5. So without any further delay, let us start answering this question and the maximum mark is 6. It is saying a particle moves in a straight line such that its velocity v meter per second at time t seconds is given by this expression v of t is equal to 4 times e to the power of negative, this is t over 3, times cos t over 2 minus pi over 4 for t greater than or equal to 0 but is less than or equal to 4 pi. The graph of v is shown in the following diagram. This is the diagram. And it is saying let t1 be the first time when the particle's acceleration is equal to 0. So part A's question is find the value of t1. It is containing 2 marks. Now, first of all, we should be, in order to answer this question, we should be knowing the relation between acceleration, instantaneous acceleration, and the velocity. So we know that this is given in your formula booklet as well. So E is equal to dv by dt. Okay. And so it is the first derivative of velocity which is giving us the acceleration. And acceleration should be equal to 0. So when we graph the velocity function, we know that for any function graph, we have the, if that function graph has any maximum or minimum points, the staging points, then at those points, the first derivative value of that function expression will be equal to 0. We know that. And we are having this velocity function graph in front of us. And of course, we are having, this is paper 2, we are given the velocity expression. So we can draw this graph in our calculator as well. So we know that if we get the velocity function graph, I think this is the maximum point so far as I feel. So at this point, the corresponding t value will be t1. At this point, the acceleration should be equal to 0 because this is the maximum point. So the first derivative has to be equal to 0 and the first derivative of v is the acceleration. So let's see. Okay. First of all, let us graph this in our calculator. So this is the calculator page. I have to go to the graph page. Okay. And this is, I have to input the expression 4 times e to the power of negative. Now don't put t, it is always x. Okay. So that will be x over 3 and yeah, times by, not, okay, times by cos, and make sure that your calculator is set to radians. Okay. So this is in radians. So cos, again, x over 2, not t over 2. X over 2 and minus pi over 4. So it is pi over 4. Why is it? What has happened? Okay, pi over 4. Fine, I feel that I have entered the expression correctly. Let's see. Enter. Yeah, I have got this graph. Why was it giving me a warning error, syntax error? I don't know. But anyway, this is the graph that I'm getting. Now I have to change the window settings because t is between 0 and 4 pi. So let us take the window settings from x to 0 and 4 pi. So this is 0 and that one is 4 pi. Okay. And the y values, let them stay as it is. Fine. So as you see, I think this point is the maximum. Let me see. Analyze graph and the maximum point. Yeah, this is the I think so. The t value has to be up to 3 significant figures. It should be 0.395 seconds. That is t1. But if you're not sure, it is the maximum point. We have got that. But in case you are not sure of this expression, that when it is the maximum of a graph, the first derivative of that function graph at that point is equal to 0. You should be knowing that. But in case you do not remember that, in that case, what do you do? In that case, take the you can take another expression, and you will be just taking the derivative of v to graph the acceleration. Okay, to get the acceleration graph. So I can take this one, and it is d by dx, this one. Okay, and yeah, ddx, and of, see, this was f1. Okay, so I need to differentiate this expression. So it is f1 variable. See, there's only one f1. So f1 x. Okay, and I come over here and enter. See, I have got this red colored graph. This is the acceleration graph. And for this, acceleration has to be equal to 0. So, first time, because over here, this is 0 again, this is 0 over here. So, first time, I have to take the first time. So, menu, analyze graph. This time it is the 0. And what happened? Which graph? So, it is this graph. And you see, you are getting exactly the same values. Means not the y values, but the x value is the same. 0.394791. Okay. So we had got the correct time t1 value from the previous graph also. But in case you don't recognize this feature, that the maximum point, because maximum is coming before the minimum point of the graph of v. Therefore, the maximum point is the stationary point. At that point, the a value has to be equal to 0. Okay. If you recognize this property, then you can just draw the velocity function graph and get its maximum. The x value will be giving you the t1 value, or else you have to draw the acceleration graph to get the and find it 0 to get the t1 value. Okay, first 0. So it is 0.395 I'll be writing. Okay. So using GDC graphs, we find that the maximum of the velocity graph occurs at t equal to 0.395. Okay. 0.395 seconds. You may write the maximum of the velocity graph, or you may write the 0 of the acceleration graph. You have to use any of this. Okay. But you have to write how are you getting the value, because it is containing 2 marks. So you have to give the reason. If it contained just a single mark, then you could have given the answer, just the answer. But because it is containing 2 marks, you have to give the justification of your answer as well. Okay. So therefore, or else I can write 0.39, more number of digits, 394791. It is 394 and 791. And therefore, T1 is equal to 0.395 seconds correct to 3 significant figures. Okay. Coming to subpart B. Let T2 be the second time when the particle is instantaneously at rest. When the particle is at rest, velocity has to be equal to 0. The particle is at rest over here. I am seeing the particle is at rest over here. So I have to take this one because it is the second time. Okay. So I have to take this part. Instantaneously at rest, find the value of T2. So this one will be T2. Okay. So I have to find this. And it is containing 2 marks. Since it is containing 2 marks, so we have to give the justification as well. Instantaneously at rest implies v is equal to 0. Okay. So using GDC graphs, T2 is equal to, I need to get the, this time I need to get the 0 of the blue colored graph. So analyze and 0. And which graph is it? This graph. And I need to get the 0 over here. So it is this. It is 10.99. So it will be up to 3 significant figures I have to take. So it will be 11.0. Okay. So I can write this as 10.9956 and then 10.9956. I'm writing this because I need the t equal to T2 value for subpart C also. And for that, I will not be taking up to 3 significant figures. I'll be taking more number of digits. That is why I have written this 10.9956. Okay. So this is equal to, therefore, T2 is equal to 11.0 seconds. Correct to 3 significant figures. Okay. Now coming to subpart C. Let us start my answer for subpart C over here. Find the distance, okay, traveled by the particle between t equal to T1 and t equal to T2. What was T1? T1 also I had taken more number of digits, and T2 also I am having more number of digits. Okay, fine. And we know that the distance is equal to absolute value of this velocity function expression and integration with respect to t from T1 to T2. Okay, so this is equal to T1 is equal to 0.394791 and this one is 10.9956. Okay, and the velocity expression, I'm not, okay, let me write the velocity expression. Okay, it is 4 e to the power of negative t over 3 and cos t over 2 minus pi over 4 and dt. So this is the expression, okay? So this is equal to, now I will be using the calculator. Fine, now this time I need to come to the calculator page and I have to go to the menu and calculus and numerical integral. Okay, so the lower limit is 0.394791 and the upper limit is 10.9956. Okay, and this is the expression. I can use the, you see, this one. the velocity's expression is stored in f1 of x. So I can use the f1 of x. So I can write absolute value of f1 of x. F2 is the acceleration. Don't take the acceleration. It is the velocity. And this one is x. And let us find the answer. Okay. So it is 7.8311. This time it is the final answer. So I'll be giving the answer up to 3 significant figures. So it is 7.83. 7.83. And what is the unit? Unit is in meters. Okay. 7.83 meters. Correct to 3 significant figures. Of course, using GDC. Okay. So this completes our answering of this question. Thank you for staying with me till the end. I'm Nilanjana Sanyal. I'm an online IB Math ESL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services to my students. In case you're liking my explanation, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching my video. And please to subscribe to my YouTube channel in case you have not subscribed to my channel till now. It will be motivating me. Okay, I'll be knowing that I'm being able to help you. And we meet again very soon in our next session. We'll be solving the next question of the same paper. Till then, bye.